Okay, so today log integration is super easy. Integration of 1 over x dx is just natural log of absolute value x plus c. That's it. And integration of 1 over u du is natural log of absolute value plus c. Now you're gonna say, well, what's the difference between the second one and the first one? Those two. Oops, my bad. The first one is no different than the second one, except there is a u substitution involved on the second one. So you have to evaluate for du. So sometimes you got some situation that you might have a little bit different. So basically, there's a 1 degree difference between numerator and denominator. So in this case, it's x and 1. So they are technically 1 degree different. If you have 1 degree different on all the things, then that means the u substitution will work. So for example, a simple one would be 2x dx here. Then you should realize x is the first degree, 2 is 0 degree. So that's just going to be take out 2, 1 over x dx. And that's going to be 2 natural log of absolute value x plus c. So that's a definite integral. That's it. You're going to do the next one. 1 over 4x minus 1 dx. Now remember, you require u substitution. With the u substitution, you need to solve for d. You need to change everything in terms of u. On your last test, I'm going to say it out loud. On the last test, a lot of people do it in terms of x bound. Don't do that. Change everything to u bound. And then evaluate. If it's definite integral, then go back to x bound. If it's definite integral, stay at the u bound. That means change your boundary to in terms of u. Now, if it's a definite integral, then you want to do back to x bound because your answer should be in x bound. A lot of people left it in terms of u. I still give credit. But you should leave it back. If it's a definite indefinite integral, which is no boundary, then you should go back to x. Connor, you already finished?
No, I'm struggling with this one.
Struggling with Sudoku?
It's an expert level one.
Does it have time frame?
Yeah.
Got it? Got it? Mandy? Okay. What does the u set us here? Good. du is equal to 4 dx, right? du over 4 equal to dx. Did you do that? So therefore it's going to be 1 over u. dx is going to be du over 4. Take out 1 over 4 of 1 over u du. And this will be 1 over 4 natural log of 4x minus 1 plus c. Because this one is indefinite integral, so I want to convert back to in terms of x. Questions? No? How about integration? There was 2 different kind of questions I'm going to give you here. One is 6x squared plus 2 over x to the cube plus x dx. The second question I'm going to ask you is secant square of x over 10 of x dx. So I want you to just take two integral in this case. They are relatively easy because you can see that it's present to you the same thing. Now we're gonna give you a harder case in a second. You will have a test on next Friday, right before the break, of all the integration technique for the AB and BC. Oh, not BC. BC, we're gonna start. We're gonna finish all the AB material, which is talking about area and volume and differential equation, right before Christmas. By next year, we're gonna start all the BC material, which is all the higher level integrations and derivative, and then series, sequence, and series. Alex is done? Both of them? Cool. If you're done with both, I want you to challenge the next one. The next one's kind of challenging. So next one has a little bit higher level thinking. So would I give you that question on the next level? Yes. Because this is a BC, we should take account. We'll be able to do all the question in A, B, and BC. So the next question is going to be integration of 2x over x plus 1 squared. This is a it's much harder one. You can start with the easier one. This is the easy one. Is 1 over x natural log of x dx. But they both require two different thinking style. And I'll just give you 2 more minutes to finish up the first one. Just give me a thumbs up to let me know you finished both. Good. Eva's finished both of them. Tyler, you finished both of them. Luca, you finished both of them. Tyler is not. Okay. Gabby, did you finish the first 2? Did you finish first 2? Liam, did you finish first 2? Yep. Julia, did you finish first 2? No? Okay. Ashbel, did you finish first 2? Not yet. Margot, did you finish first 2? The third one and the fourth one are a little bit more challenging. If you don't wait for me, you can.
Is that a secant squared over tangent
Yep.
to the first?
So the key thing is to see that's one less degree than the other one. But the third one there is the same degree. And did I mention sometimes before that we talk about same degree? What do we do if it's the same degrees? You do the back sub. You do the back sub, yeah. So that you can keep on continuing to try that. I'm just going to go over the first 2. Julia, did you finish the first one? Okay, what did you set U as here? Okay, because you see that one less degree, right? 3, 2, and this is 1 one less degree situation. So that is going to be du equal to 3x squared plus 1 dx. Now, it's okay that you have different number from top and bottom, so that's going to be 6x squared plus 2 over u, and this one's going to be du over 3x squared plus 1. So what I can do is factor out a 3 on the top. Okay, so I'm going to write down 3 on the top, or 2 on the top, sorry. 2 on the top, then that's going to be 3x squared plus 1. And now 3x squared plus 1 could cancel, so it'll be 2 du over u, so it'll be 2 times natural log of x cubed plus x plus c. Mandy, you got that? Julia? Tyler, did you get that?
Yeah.
Okay. What would you, now this one does not one less degree, but it's a derivative of the other one. So u is equal to what? Tangent of x. Du is equal to what? Which is perfect, because we do have secant square of x dx here. So it'll be secant square x u and du over secant square of x. Cancel out. Perfect. Natural log of tangent of x plus c. Got it? Okay. Next two cases. Those are the two cases that I will put on the test because those are the two cases that are more challenging. So you had to think about is 2x over x plus 1 squared. So what would you do u as here? U equal to x plus 1, good. So I'm going to do u equal to x plus 1. And this is dx, don't forget about writing that. So I'm going to get u squared. And this one's going to be du because du equal to dx here. But the problem is du equal to dx here, but we have a 2x, right?
U minus 2.
So then I can back sub, which is u minus 1 equal to x. So therefore I can take out 2 outside. It's going to be u minus 1 over u squared du. Am I going too fast? Can I split this? U over u squared minus 2 integration of 1 over u squared du. Any question here? Can I simplify this down to 2 of du over u minus 2 integration of u to the negative 2 du? Can I do that? And that's equal to 2 natural log of u. What is u in this case? X plus 1 minus 2. What's integration of u to the negative 2? Will be u to the negative 1. And this is positive, right? So it'll be 2 natural log of x plus 1 plus 2 times 1 over x plus 1 plus c. And that's my answer. And this one is a somewhat harder one that require back sub. Remember, if they have the same degree, they're not 1 degree difference. In this case, it's a 1 degree difference between numerator and denominator. But in this case, they have same degree, so you can do a back sub. Am I going too fast? Keep on going? Okay. Ooh, there's a lot of options here. It's 1 over x natural log of x dx. So what I want u equal to us here. Why is that?
Because the derivative of ln of x is 1 over x.
So you kind of have to foresee that, right? You cannot do u equal to x natural log of x because as a product rule, it's just going to get more messy. And you cannot do u equal to 1 over x because du is going to be 1 over x to the negative 2 times negative 1. And that's not making the problem easier. So u is equal to ln of x. And du equal to 1 over x dx. And the x du equal to dx. So therefore, it's going to be what? 1 over x u times du x du. So x cancel out. Will be natural log of du over u. Now be careful here. It'll be natural log of x plus c. Natural log of natural log. So it's not natural log of this. It'll be natural log of natural log. How much time I have? 4 minutes? Okay, we're going to talk about this one. How do I integration of tangent of x? Well, tangent of x, I can rewrite it, right? So it's what? Sine of x over cosine of x, right? Now you see that the bottom, if you take a derivative of the bottom, is equal to the top, except it's opposite signs. So u equal to cosine of x, du equal to negative sine of x dx. Now this is the one that I would tell students to memorize, but it doesn't matter. If you don't memorize, it's fine. Sine of x dx, that's equal to that. So it's going to be u and du over sine of x, but it's negative, and sine of x, and that's what sine of x here. That's why it's a negative natural log of cosine of x. Sorry. Yeah, cosine of x plus c. So in same thing, you can do it for cotangent of x as well. But here comes down the very, very interesting problem. Is how do we do integration of secant of x? Okay, how do we do integration of secant of x dx? That was kind of hard. Now, usually you have to memorize this, but I'm going to show you how to prove it. And the people come up with this stuff is truly, truly impressive, creative. It's like you cannot come up with this. You cannot make up this. You can actually you have to really have imaginary creativity to do integration of secant of x. And I'm going to show you how they did it. It's pretty cool. It's truly amazing what they come up with. They say, I don't know how to do integration of secant of x because that's 1 over cosine of x. If I set u equal to cosine of x, it doesn't have a du on the top. Nothing I can resolve. So there is something that you can change. If you can change, how would you change it? Now, this guy, whoever come up with this, I don't know how in the world he think like this. Is he take the secant of x and he multiply by secant of x plus tangent of x over secant of x plus tan of x. You're going to see something is pretty cool because if I distribute the top, it's going to be secant square of x plus secant x tan of x. Do you see that? And do you see what am I going with this?
Yes. Now it's in the correct form. It's u prime over u.
Yes. The tangent of x, derivative tangent of x equal to secant square of x. Derivative of secant of x equal to secant tan. So therefore, u equal to secant of x plus tan of x. So I always say mathematicians are truly creative. Secant of x, tan of x, plus secant square of x dx. Now if you see this, it's going to be natural log of secant of x plus tan of x plus c. And that's it. Because secant tan cancel out, secant tan x plus secant square of x cancel out with the top. And that's what, and so I think that's truly amazing what mathematician can come up with. It's just the creativity, the awesome way to think about algebraic solutions to figure out how to do that. But yeah, you guys gonna have all the integration over the weekend and also all the derivatives. Because I can move this to the other side. And then that's gonna cancel out.
Are we taking like the derivative? Are those parentheses are absolute value?
Absolute value.
Okay.
I mean for the natural log, it's gonna be absolute value. You're welcome. All right.
Is it possible for me to go over my test during 7th grade?
Yeah.
I
Just come back in because she's still taking it, so that's a problem.
Okay.
Otherwise, I'll give it back already.
Yeah.